Unit 4 of AP Environmental Science focuses on some basic earth science. It hits on some geology, some atmospheric science, meteorology, hydrology, atmospheric science. All these things are sort of combined in this unit. And so we're going to start by talking about plate tectonics. So this will be a review generally for most people from earth science. But to understand the resources that we have on Earth, we need to understand that they are finite. The minerals, the metals, the elements present on Earth were formed at the formation of the Earth 6 billion years or so ago. And so they are finite. And the Earth is generally a closed system. There's not material leaving the Earth or coming into the Earth overall. And so if we think about the Earth as a planet, we can look at the different layers that are present in the Earth, and they're called the inner core. Then there's the outer core beyond that, the mantle, and finally the part of the Earth that we experience most directly is the Earth's crust. If we were to go and extend beyond that, then we would be getting beyond the crust into the layers of the atmosphere, which we'll study later on. If we look at sort of those layers, the inner core of the Earth is a solid layer. It's surrounded then by a liquid layer, the liquid core, and then there is the mantle, and finally the solid crust that sits atop that. The term we use for the crust and the solid upper parts of the Earth's surface are called the lithosphere. Okay. And so we could look at sort of how big is the Earth, what is the diameter, etc. And so this map here shows us the dimensions and compares it to the United States, where the vast majority of the Earth we don't experience the inner core, outer core, the mantle. The lithosphere, where we spend our time, is really a relatively small proportion of the entire cross-section of the Earth. But we know that the Earth's crustal plates, the plates of the lithosphere that are on top of the Earth, they are less dense than the mantle that's below them. And therefore, they're sort of floating on top of that mantle. But they're not static. Okay? The Earth's core itself is very hot, and that heat causes these convection currents to form as hot magma within the Earth rises and creates these circulating convection currents. And it forms hot spots at the surface of the Earth. And what happens in these situations is the plates of the lithosphere are actually moving relatively slowly over the surface of the Earth. And these subsurface activities of the mantle have impacts on the surface of the Earth. Creates things like subduction zones and volcanoes, mountain ranges, and ocean spreading, etc. And so we'll look at that in the next few slides. The area where we have two plates that meet, we call that a plate boundary. And there's different types of plate boundaries that are present on the Earth. One type is called a convergent boundary, where you have two plates that are converging together, moving towards each other. And we can see that here in this model. What we have is two plates, one coming from the left, one coming from the right, and they are converging with each other. Okay? And depending on the type of crust, the oceanic crust is more dense. It sinks below. It gets subducted, we call that, under the continental crust. And then as it melts, it can lead to the formation of volcanoes in these areas where you have convergent plate boundaries. It leads to deep ocean trenches where this subduction is happening. It can also lead to mountain building where these plates converge and get in the areas of the lithosphere get uplifted, forming these mountains. Can be an area in which we have earthquakes as well. That's a convergent boundary. The opposite of that is a divergent boundary, where you have two plates moving apart from each other. They're pushing away from each other. We can see that in the Atlantic Ocean. The mid-Atlantic ridge is a divergent plate boundary, where we have two plates that are moving away from each other on the east and on the west. And so what happens when you have that is you have seafloor spreading. You have new magma material coming to the surface at this divergent boundary. And that forms new layers of the lithosphere. New rock is forming here. This is the youngest rock that's present here in this mid-Atlantic ridge. And then the seafloor is spreading and the ocean is getting larger here in the Atlantic. This results in rift valleys in some cases, can result in volcanoes along these boundaries as well. Earthquakes can also be present in this divergent boundary. And then we have a type of plate boundary that's called a transform boundary. This is where plates are not moving towards or away from each other, but sliding past each other. And in a transform boundary like this, we have the rock on the right part of the lithosphere. That plate is moving this way. The other plate is moving the opposite. And what happens along these boundaries, along these transform boundaries, is sometimes the movement of the plates, they bind together until the energy builds up so much that they then give and slide across each other. Those are areas of very frequent earthquakes when you have these transform boundaries sliding against each other. And so we can see here in this map of the Earth that shows major plates, you can see the movement of those plates. The plates are all moving. In some areas we have convergent boundaries, others we have divergent boundaries. So if we think about sort of where we are right here, we are on the North American plate. Okay. If we look at the Eurasian plate, that's to our east. Okay, what we see is this is a divergent boundary, like we talked about along that mid-Atlantic ridge, where the Eurasian plate is moving generally eastward, the North American plate is moving generally westward, and so we have a divergent boundary there. And you can see that's what these green lines represent. The transform boundaries, where the plates are moving next to each other, are in black here. One area we see that is a Juan de Fuca plate, which is up here. And we have, an area along our west coast of North America where we have frequent earthquakes because of this transform boundary that we see. We also have convergent boundaries, which are in this pink color. For example, here we have the Australian plate moving into the Pacific plate. That's a convergent boundary here. We can see other convergent boundaries along the way. And so we know over the history of the Earth, these major plates have moved over time, and we can see that. Here. We also know that these plate boundaries become important when we're thinking about volcanoes and earthquakes. If we were to compare the plate boundaries from this map with major zones of earthquakes and volcanoes, we can see that they align quite well. We could see the mid-Atlantic ridge of this diverging boundary. Okay? We can see along here in the Pacific, we have these plates that are moving, converging with each other. You can see that here. We can see the Pacific and the Pacific plate here, which is diverging over here. And so these are areas where you have lots of earthquakes and lots of volcanoes as well. You can see this boundary here where we have abundant volcanoes and earthquakes. And they generally align with each other. There are some areas, for example, where you have hot spots, such as the Hawaiian Islands. These are not on plate boundaries. This is in the middle of this Pacific plate. But there's still areas of volcanic activity. We'll talk about why in just a couple slides. So we can use these plate boundary maps to understand where we would often find volcanoes, where island arcs form, where there are earthquakes, etc. So these plate boundaries can give us a lot of information. One thing that I just mentioned is this hot spot, these hot spot volcanoes like we see in the Hawaiian Islands. Here's a map of the Hawaiian Islands. Okay, the big island of Hawaii, Maui, Molokai, etc. So you see the Hawaiian Islands here. Okay, and there's a series of islands And to understand why these islands are forming, let's look at the model on the right. These islands, these hotspot islands, form because there is an area of the mantle where you have a relatively thin ocean crust, and there's a hot spot in the mantle producing large amounts of magma, which eventually rises and forms these volcanoes. So this oceanic crust plate is actually moving from left to right. So it's moving relatively slowly in this case. And so as this volcanic island forms over time, the plate moves. But the hot spot that's below it in the mantle does not move. It stays stationary. So even though the plate moved and this volcanic island has drifted to the right, a new island is forming here. And then a new island forms again. So we have this series of islands that are forming because the hot spot is stationary, but the plate is moving. And so we have the oldest islands are in this direction. And then over here we have the youngest island. By determining the age of the rocks that are formed on these islands, we can actually determine the speed that this plate is moving in. And so the Hawaiian Islands are an example of this. Here is the hot spot. Okay. There's actually a new island forming here, okay, over this hot spot. Hawaii is the youngest island that's present. Okay. It is about 0.4 million years old. And so the oldest islands are up here because this plate has been moving in a northwestern direction. The oldest plate here is formed almost 5 million years ago when this spot was over the hot spot, but since then it has moved in a northwest direction. So we can tell the speed of movement, and we can tell where these hot spots are by looking at these hot spot island arcs. We also know earthquakes can form when we have plate boundaries that bind, and then the energy stored up gets released, forming an earthquake. And we can see there's different types of earthquakes depending on the type of boundary there is. They can be quite extreme, as we see here, okay, where you have this giant rift formed in the land. Here we can see again a pattern that follows the major plates, and we could also see the magnitude of these different earthquakes that formed in various places throughout the earth.